There we go. Here's an example. Elevator with a maximum capacity of 16 passengers has a total weight of 2,500 pounds. Okay, that's our maximum capacity for that particular elevator. Assuming a worst case scenario in which passengers are all male, because they tend to weigh more, what are the chances of the elevator being overloaded? Assume a male weights follow a normal distribution. So they're telling us male weights follow a normal distribution with a mean of 182.9 and a standard deviation of 40.8. So we've gotten the information from the problem that it's a normal distribution, has a population mean and a standard deviation for the population. Okay? It says find the probability that one randomly selected male has a weight greater than 156.25 pounds. Okay? That's a probability. We're dealing with a normal distribution. What do we use to find that probability? Normal CDF. And since it's greater than, we're going to the what of 156.25? To the right. Okay? So we can either convert 156.25 to a z-score, or you can change the mean and standard deviation on the calculator. And you're doing a standard deviation or a normal CDF of 156.25 as your, well, that could be your, we want to the right, so your lower bit would be 156.25. Your upper would be what? 180 to 99. That gets us to the infinity side of things. We put a mean of 182.9 and a standard deviation of 40.8, and we can get that. My PowerPoint converts to a z-score and does the same thing. Okay? Whether you convert to a z-score or just change the mean and standard deviation, this is what we're looking for. Okay? Is this area under that curve. We know it's the 156.25 to the left because it's less than the mean. You know, the mean's always in the middle of normal distribution. So out of that. So if we find that area, it'd be 0.7422. We do that with our calculator. Okay. Now, B part, go back and read the question without seeing the word. Probability that a sample of 16 males has a mean weight greater than 156.25, which puts the total weight at 2,500 pounds, which is overload capacity. Right? So exceeding the maximum capacity. Here's how we can do that. We know that the mean of the sample means is equal to the mean of the population, so we know our mean is 182.9. The mean or the standard deviation of the sample means is found by this formula. Okay. We know it's 40.8 for the population, and sample size is 16. So we do that work there. That's our mean and standard deviation for that distribution. All right. So mean 182.9. It's the same mean we had before, but our standard deviation is different because it's of the sample means. 10.2. We're looking for greater than 156.25. Find that area of that. And if we do that, we get this statement is confusing. The top part is the answer to A. It didn't really affect me. Okay. B part, the probability of that the sample of 16 males will have a mean weight greater than 156.25 is 0.9955. Okay. So calculator. Distributions, normal CDF, our lower 156.25, right? Our upper 1E99. Our mean is 182.9, and that's the right number. Yeah, and our standard deviation, because it's of the sample means, we use that little formula of the 40.9 or 40.8 divided by square root of 16, which got us 10.2 out of that. So we're finding that area, 0.9955. Okay. So again, this stuff is not getting harder. It's the same stuff. It's just applying it to different situations. Okay, it's the same stuff, just applying it to different situations. All right. Correction for a finite population. Okay, so when we're sampling without replacement and the sample size is n is greater than 5% of the finite population of size capital N. Lowercase n, it's greater than 5% of capital N. Then we can do this correction to the standard deviation of the sample means. A little correction that you've got to put in there. Make sure you got that corner. Doesn't come up very often, but it's again that 5% rule. That's the same 5% we've been dealing with for the whole time. Okay. That is the last thing for this. I'll have problems up on Classroom. If you'll check there, I'll put it in the announcement what problems to do if you want to start on them tonight. Okay.